Hi everyone. Okay. So guys, today is our sixth class for the BGP, right? Okay. So till now we discussed something about the BGP. I think we are discussing about the BGP messages. Okay. So till now we discussed about the TCP connections, right? This is the router 1, router 2. When you configure the BGP on a router 1 and router 2, both router establish a TCP connection. Why? Three-way handshake. Right now, we already discussed these things. When TCP connection was established, then what is the first BGP message? That is called, guys, open message, right? And after that, we discuss which message, guys? Keep alive, right? So till now we discussed these three things. Okay, right, everyone? Okay. Now I hope my screen is visible to all of you. So guys, see here. I think till now we discussed these things. We have a router 1 and router 2. On router 1, we configure router BGP 100, and on router 2, we configure router BGP 200. Clear? This is the AS number 100, and here I configure AS number 200. So the neighborship between R1 and R2 is called eBGP neighborship. Why? Because both are in different AS. Clear? Now, when I configure the BGP, first of all, router number 1 start sending one TCP packet. Yes or no? Yes. In TCP packet, there are mainly three things. First, in TCP packet, there are flags. I already show you guys, if you guys remember. Right now, in this TCP flag, R1 is sending SYN bit. In this TCP packet, R1 is sending SYN bit on. Okay. And what is the source port number? Source port number will be any random port number. I told you the device which initiate the TCP packet, that device use any random port number. Okay. So that's the reason source port number is any random port number. What will be the destination port number? Destination port number will be BGP port number, that is 179. Getting my point? So this is the TCP packet R1 is sending. This packet will reach on R2. R2 reply with TCP packet. And in this TCP packet, R2 sending SYN bit as well as acknowledgement bit. Both bit is on, right? This acknowledgement bit is, this is the acknowledgement of this SYN. And R2 is sending its own SYN. Fine. What is the source port? 179, and destination port is random port number. Not random. This destination port is, this is the port number of R1. Yes or no? Yes. And now when this TCP packet will reach on R1, R1 send again one TCP packet, and in this TCP packet, R1 is sending the acknowledgement of this SYN. Getting my point? And that is called three-way handshake. That is called three-way handshake. Okay. So guys, by this way, what happened? TCP connections established between R1 and R2. Fine. When TCP connection will establish, both router both router store the TCP connection information in which table, guys? TCP table. Right now, what is the command to check? So TCP brief. Right now, so this is the command by which you can check this one. Clear? So these things we already discussed. When both router establish a TCP connection, then after both router start exchanging first BGP message, that is called open message. So R1 is sending the open message, and I told you in open message both router exchange the neighborship parameter. Both router exchange the neighborship parameter. Getting my point? R1 is sending, what are the content in open messages, guys? So these are the main content in the open messages. First is length, that is type. What is the type? What is the type value for open? Please remember 1. What is the type field will be 1. Okay. Version, this is the BGP version. My AS number, R1 is using AS number what? 100. Getting my point? So that's the reason my AS number is 100. By default, what is the hold timer? Hold timer is 180 seconds. What is hold timer? Hold timer means any router will wait till 180 seconds. If an keep alive message will not receive, then after that router will break the neighborship. Again, I am telling, I told you there is next message that is called keep alive message, and keep alive message is periodic message, right? After every 60 second, both router exchange the keep alive message to maintain the BGP sessions. Yes or no? Yes. But let's suppose if anyhow any router will not receive the keep alive message, so in this case, router will wait till the whole time, that is the 180 again. If the router will not receive keep alive messages till 180 second, then this router will consider its neighbor as down. Getting my point? So that is the use of hold timer. Now, what is BGP identifier? This is just like a router ID. Getting my point? The election criteria is exact same. We already discussed these things. Fine. So these are the content R1 is sharing in its open message. Again, these are the content R2 is sharing in its open messages. Clear? When both router agree on that parameter, then after both routers start sending the keep alive messages. Getting my point? And one more thing, if you guys remember, I already told you router exchange open message only one time, only one time. This is not periodic. This is not periodic. Getting my point? But keep alive messages are periodic. It means both router exchange the keep alive messages after every 60 seconds. Getting my point? What is the use of keep alive message? To maintain the BGP sessions. Clear? I hope these things we already discussed and you guys already remember these things. And in keep alive messages, there are nothing, only two things. Type field. What is the type field for keep alive? 4. And this is the total length, total size of keep alive. Getting my point, everyone? Now, now we are going to discuss the next message that is called update message. What is guys? Update message. Getting my point? Now, the first point about the update message, when router generate the update message. Yes. Sorry. What is the question? Yes, I got your question. So basically you are asking कि sir, can we change the keep alive or hold time? My answer is yes. Yes, guys, we can change the keep alive time as well as hold time. What is the command? If you guys want, you guys can write down. For example, on R1, I want to change. First of all, I will write router BGP 100. After that, you have to write neighbor. What is the neighbor IP address? 12.2, 12.0.0.2. Getting my point? After that, you have to write timers. What? Timers. And after that, here you have to write the keep alive time. And after that, here you have to write the hold time. So basically, this is the command by which we can change the keep alive time as well as hold time. I hope you guys understand. Clear? Everyone. Okay, cool. Now, the next message is, guys, update message. Now, the first point is when router generate the update message. When router generate the update message. So, guys, please focus here. I written 2 point here. Please read this line. Router exchange BGP update message when router need to advertise any routes in BGP. Please remember, for example, this is the router number 1. On this router 12.1, and here I configure one loopback. This is the router number 2. Here we configure 12.2 and here one loopback 2.2.2.2. Here we configure BGP 100 and here I configure BGP 200. Are you getting my point? Yes or no? Yes. Now we configure on R1, this is your neighbor, and on R2 I configure this is your neighbor. Getting my point? Yes or no? Yes, everyone. Now tell me one thing. 12.1 and 12.2 both are directly connected with each other. It means both are already reachable with each other. There is no problem. Getting my point? But if you try to ping from R2 to 1.1.1.1 or try to ping R1 to 2.2.2.2, you are not able to ping. Why? The reason is The reason is, if you check the routing table of R2, you guys will not find 1.1.1.1 in its routing table. Getting my point, everyone? Yes or no? And when you check R1 routing table, you guys will not found what 2.2.2.2 in its routing table. Getting my point, everyone? Yes. Why? Because still we do not advertise this one and this one in BGP. So if you do not advertise these things in BGP, how R2 will know about one network and how R1 will know about two networks? Getting my point? So if you want to make communication possible between these two loopback, you have to advertise these two loopback in BGP. Otherwise, you are not able to communicate. Getting my point? And now, see, what is the first point? First point is router exchange the BGP update message when router need to advertise any route in BGP. So see na, on R1 there was one loopback 1.1.1.1. What I will do? I will advertise this route in BGP. I will advertise this prefix in BGP. Getting my point? And that is called NLRI. NLRI stands for Network Layer Reachability Information. What is NLRI? Getting my point? NLRI means 1.1.1.1. This is NLRI. On R2, what is NLRI? 2.2.2.2. This is NLRI. Getting my point, everyone? So I hope you guys understand. When router generate the update, the first condition, when you advertise anything in BGP, in this case router will generate the update message to inform its neighbor. Are you getting my point? R1, R2. On R1 there is one loopback 1.1.1.1. On R2 there is one loopback 2.2.2.2. Let's suppose on R1 I write the advertise BGP advertise command. What is the command? We will discuss it later. But let's suppose I write on R1 one command to advertise it. What R1 will do? R1 generate the update message, and in update message, what is the information? 1.1.1. That is called NLRI. R2 generate the update, and what is the NLRI? 2.2.2.2.2. This update message will reach on R2. This update message will reach on R1. What R1 will do? R1 update its routing table with 2.2.2.2. R1 updates its routing table with 1.1.1.1. Getting my point? So basically, this is the use of update message. By the help of update message, both router exchange the prefix information with each other. So both routers routing table is up to date. Getting my point, everyone? So this is the first condition. Now, second condition is router exchange the BGP update when any route removed from the BGP table, and that is called withdrawn routes. Guys, try to understand what I'm trying to say. For example, R1, R2. Getting my point? 12.1, 12.2. There is loopback. There is loopback. Clear? I don't think anyone have any problem right now. Okay. This router maintain one BGP table, and this router also maintain one BGP table. One BGP table. Okay. One more thing. In previous class, I already told you, if you guys remember, in case of EIGRP, whatever you were advertising in EIGRP store that information in which table? Topology table. Getting my point? Similarly, here in BGP, whatever you are advertising, router store that information in which table, guys? BGP table. Getting my point, everyone? Now come on R1. On R1, when you check the BGP table on R1, you will find 1.1.1.1. Yes or no? Yes, because we advertise 1.1.1.1 in BGP. So this is the information in BGP table. As well as in BGP table, you guys will found 2.2.2.2. Why? Because R2 already share the update packet. Yes or no? And when R1 receive the update package, what R1 will do? R1 check the NLRI information and store that prefix in which table? BGP table. Getting my point? Similarly, in case of R2, On R2, what is the BGP table? 2.2.2.2 and 1.1.1.1. Are you getting my point? Yes or no? Yes. Let's suppose anyhow this prefix is or this network goes down. What R1 will do? R1 will generate again which message, guys? Update message. So when this prefix will goes down on R1, first of all, R1 will remove this information in which table? BGP table. Are you getting my point? In which table? BGP table. Fine. After remove this information from the BGP table, R1 want to update the same information with its neighbor, that is R2. But how? R2 generate one update message. To generate one update message. In update message, there are one field. I will tell you in detail way. In update message, there are one field that is called withdrawn routes. Withdrawn routes. And what is the withdrawn routes? In withdrawn routes, you will found 1.1.1.1. Why? Because on R1, 1.1.1 goes down, and R1 share this prefix with this update packet with R2. So when this update packet will reach on R2, R2 check in this update package there is nothing NLRI. There is withdrawn routes. Withdrawn route is what? 1.1.1. What? Immediately R1 delete this information from its BGP table. Getting my point? So that's the reason I told you there are two conditions when router generate the update message. First, when you advertise anything in BGP, and second, when any prefix goes down in from the BGP table, or when in any condition when any prefix is removed from the BGP table. In this case, router generate the update message to inform its neighbor, and by the help of this update message, router is telling to its neighbor, hey bro, if you install this route, why me, so please remove it. Getting my point? So that is the use of update message. Getting my point, everyone? I hope you guys understand. Now the next point is, if no route are being advertised or withdrawn, router will exchange only keep alive message to maintain the BGP neighborship session. I already told you this one. R1, R2, if let's suppose 12.1, 12.2, 1.1.1.1, 2.2.2.2. Let's suppose I configure here BGP and here I configure BGP. Still, I do not advertise anything. What R1 and R2 will do? R1, R2 exchange only three messages. First, TCP. Second, after TCP, open. And third one is keep alive. Both router never exchange the update message because you didn't advertise anything. Because you didn't advertise anything in BGP. Getting my point? So in this condition, routers only exchange TCP, open, and keep alive. Getting my point? And open message only one time, but keep alive message router exchange after every 60 seconds to maintain the BGP sessions. Getting my point, everyone? Now, the BGP update message is used to exchange routing information between BGP neighbors. Yes, we already know. It can advertise new routes and update attributes associated with existing routes. Guys, try to understand this point. This means, let's suppose R1 and R2, 1.1.1.1. R1 is sharing update message. Let's suppose I advertise 1.1.1 in BGP. What R1 will do? R1 generate the update message. In update message, router not only exchange the NLRI, that I am telling, no, R1 will not exchange only 1.1.1. Apart from this, router include the path attribute also for this prefix. There are multiple type of path attribute. We will discuss these things in a detailed way. But right now, just understand, in update message, router exchange the prefix information as well as the path attribute for that prefix. Getting my point, everyone? Now, the update message is critical component of BGP as it enable dynamic exchange of routing information, ensuring that all BGP router have consistent and up-to-date routing table. Yes, If router will not exchange the update message, then how router and its neighbor will update its routing table? It's not possible. So what is the main use of update message? By the help of update message, both router is up to date. Both router is up to date. It means both routers routing table is up to date. Getting my point, everyone? If no, if a route is no longer valid or available, update messages are used to withdraw those route. Yes, I told you this is the use of update message. By the help of update message, let's suppose on R1 this route is not available in the BGP table. So in this case, R1 will generate the update message, and in this update message 1.1.1.1, that route will be the withdraw route. Getting my point? And by the help of this update message, R1 is telling to R2, you have to remove it from your BGP table also, and you have to avoid use 1.1.1.1. Getting my point, everyone? I hope you guys understand. Clear? Now, next. Okay. Now, before this, guys, first of all, I tell you one thing. See, on R1, I write this command. Please remember this command. On R1, I write router BGP 100. After that, I write network 1.1.1.1 because I need to advertise this one. Guys, what is this? This is the command for advertise. This is the advertising command. So by the help of this command, you can advertise any prefix in BGP. Getting my point? So on R1, what I am writing, network, I want to advertise this one. So I write 1.1.1.1. After that, I have to write the keyword mask. And after that, you have to write the subnet mask of 1.1.1. That is this one. Getting my point? So basically, by the help of this command, you can advertise any prefix in BGP. Getting my point? Similarly, on R2, you have to write network 2.2.2.2 mask 255.255.255.255. Basically, this is the command by which we can advertise any prefix in BGP. Getting my point? Anyone who do not understand, please tell me. Clear? Okay, cool. Now, okay, this is the command by which we can advertise anything in BGP. Clear? After that, we have a next thing, that is component in update message. Component in update message. Okay, so before I start, guys, component, first of all, there are some rules. See, when we try to advertise anything in BGP, we have to remember these information. We have to remember these information. Otherwise, you will face the challenges. Getting my point? Okay. First of all, let me open my topology. Guys, this is our topology. Come on, R6. Let me configure the BGP here first. Router BGP 100. I am writing neighbor 12.0.0.2. What is the remote AS? 200. Are you getting my point? Exit. Now, come on R7. Router BGP 200. Neighbor 12.0.0.1. Remote AS is 100. Yes or no? Are tell me. Are tell me, everyone. Yes or no? Yes na? Okay. How can you check? So IP, sorry. So TCP brief. See, I told you na, by the help of this command, you can check the TCP table. Yes or no? Yes. So TCP brief. So this is the local IP address 12.0.0.1, and this IP address is using any random port number. Yes or no? This is the neighbor IP address 12.0.0.2, and your neighbor is using the BGP port number that is called 179. And what is the state? State is established. It means TCP connection is established. There is no problem. Now, So BGP summary. See, so by this command, you can check the neighborship. Who is the neighbor? 12.0.0.2 is the neighbor. What is the version? 400. Your neighbor, sorry, 4, and your neighbor is using AS number 200. How many messages we received? 2. How many messages we sent? 2. Getting my point? And what is the state? State is nothing. State is blank here. If a state is blank, it means it's already established. Our neighborship is already established. Getting my point? And what is this? Prefix received is 0. It means R6 do not receive any prefix from its neighbor R7. Why? Because still on R7, we do not advertise any prefix. If I do not advertise any prefix on R7, then how R6 will receive any prefix? It's possible? No. Are you getting my point? Tell me yes or no? Yes. And I told you one more thing. Whenever you advertise any prefix, router store that prefix information in which table? BGP table. What is the command? So IP BGP. See, in BGP table there is nothing. Why? Because still on R6 we do not advertise anything, as well as R6 do not get any prefix from its neighbor. So that's the reason its BGP table is right now empty. There is nothing. Getting my point? Everyone tell me. Clear? Now. Now I told you how we can advertise the thing. Getting my point? So before advertise, first of all, you have to remember these rules. What are the rules? Please see here. The prefix you want to advertise must be present in your local routing table. Getting my point? The first rule is, if you want to advertise any prefix, that prefix must be present in your local routing table. If local router doesn't know the prefix, BGP won't be advertised it. If that prefix is not present in your local routing table, you are not able to advertise it. Are you getting my point? Everyone, not only this. Not only this, BGP will only advertise a prefix if its subnet mask matches. If its subnet mask matches. Do you understand this rule? No. See here. What this rule mean? Everyone, please focus. Come on R6. First of all, check the routing table. So IP root. So I want to advertise 1.1.1.1 in BGP table. Yes or no? Yes. I want to advertise 1.1.1 in BGP. So see na, here in local routing table 1.1.1.1 is present. So according to my rule, first condition is satisfied, that the prefix is present in my local routing table. What is the second part of this rule? If you want to advertise any prefix, subnet mask must match. It means in your local routing table, 1.1.1.1 is present with subnet mask /32. Yes or no? Yes. So whenever you are advertising any prefix in BGP, you must need to remember, whenever you are advertising, you must advertise that prefix with the same subnet mask that is present in your local routing table. Getting my point? Understand? Yes or no? Yes. Yes, na? Okay. See here what I am trying to say. For example, come on R6 conft router BGP 100. What is the command to advertise? Network. After that, which prefix you want to advertise? 1.1.1.1.1. After that, you have to write mask. After that, you have to write the subnet mask. Let's suppose I am writing 255.255.255.0. I write this one. See now, what is the error I am getting? Incorrect network or mask prefix length configured. It means I am advertising 1.1.1, but I am using the subnet mask what? /24, but this prefix is present in my local routing table. Why? /32. I show you na, slash, are tell me, /32, and I am advertising with /24. So that's the reason you are getting the error. Getting my point? Everyone, I hope you guys understand. Are you getting my point? So if I write here, can I write? Okay. So before write this command, let me capture this link. So I will show you the content in the update message as well. Clear? Okay. On R6, I write this command. So basically, guys, this is the use of, what is the use of this command? By the help of this command, you can advertise the prefix in BGP. Yes or no? Yes. Now, so when I advertise this one, check the BGP table. So IP BGP. See here. Now, this prefix is present in my BGP table also. Now, this prefix is present in my BGP table. Yes or no? Everyone, anyone who do not understand? Yes. Now, guys, there is one thing. What do you mean by this? Star and this. Any idea? See here. Star means what? Star stands for valid. Star stands for valid and greater than sign. This stands for best. It means this prefix is valid as well as best. Both. Are you getting my point? Everyone. Tell me yes or no. Yes. This prefix is valid as well as best. Getting my point? And there is one more rule related to this. Rule is rule is if any prefix if any prefix is valid as well as best in its BGP table, then after router do two things. First, router will install that prefix in its local routing table first, and second, if that prefix is valid and best, then after router will share that prefix with its neighbor. So this is the rule. Rule is when any prefix is valid as well as best, then after router will perform two things. Router store that prefix in local routing table. That is the first thing. And second one is router will share that prefix with its neighbor. Getting my point? Let's suppose in any scenario, this prefix is only valid, not best. In this case, what will happen? This router do not install that prefix in its local routing table, as well as this router never shared that prefix with its neighbor also. Getting my point? I will show you these things later. Okay. Now, next is, guys, next hop. Next hop is 0000. What do you mean by 0000? It means 1.1.1.1 is advertised on R6. On R6. Guys, basically, na 0.0.0.0. When you see the next hop 0.0.0, it means you can understand like this. This prefix is self-advertised. This prefix is self-advertised. It means 1.1.1 is advertising by router number 6 itself. Getting my point? R6 is not, let's suppose if you find here any other IP address. For example, here, let's suppose you get 12.12.0.0.2. It means what? It means this prefix R6 is receiving this prefix by R2. Getting my point? So what I am trying to say, if in next hop, if you found 0.0.0.0, it means this prefix router is advertising by itself. If apart from 0.0.0, it means this router is getting this prefix from any other router. Getting my point? That is the use of next hop. Getting my point? Everyone. These are the path attributes. What are these path attributes and what are the uses of these path attributes? We will discuss these things later. Getting my point? Understand? Anyone who do not understand, please tell me. Okay, cool. Now, let's suppose now on R6 we write the which command, guys? Network command. Fine, na? So by the help of network command, we are advertising 1.1.1.1. Getting my point? Now R6 start sending which packet, guys? Start sending update message. Yes, na? Because R7 know about 1.1.1.1. Why? Update message. Yes or no? Everyone, yes or no? Yes. See, R1. I hope this is visible to all of you. See here, guys. Who is sending the update message? R1 is sharing the update message. Yes or no? Arey, R1 is sharing the update message. Source IP address is 12.1. Destination IP address is 12.2. Okay. Let me open the update message. See here. Length, size, update. What is the type field? Type field is 2. Arey, tell me. See here. Content. What is content? This is marker. This field is used to detect the start of the new messages. Clear? This is not our use. Now next is, guys, withdrawn route length. Withdrawn route length, I told you na, this field show the length of the withdrawn routes. Length of the withdrawn routes. But right now on R1 you write the network command, and by the help of network command you are advertising anything. Right now nothing is remove from the BGP table. So that's the reason in this case you will found withdrawn route length will be 0. Are tell me yes or no? Withdrawn route length will be 0. See na? See, withdrawn route length. What is the withdrawn route length? 0. Why? Because right now nothing is removed from the BGP table. Yes or no? Yes. Now next is, guys, withdrawn route. Again, in withdrawn route, see, nothing is there. Withdrawn route. Where is withdrawn route? Withdrawn route, there is no withdrawn route. Why? Because we are not removing anything from the BGP table. We are not removing anything from the BGP table. Are you getting my point, everyone? Tell me yes or no? Yes. Length, this is the total size, I already told you. Type, are you tell me? Type, type is for update message. What is the type? Type is 2. What is the type for update message? See na, type is 2. Are you getting my point, everyone? Now, total path attribute length. I told you whenever router will exchange the update message, router share the prefix information along with attribute. Yes or no? Yes. If router is sharing the attribute, it means there will be a size of attribute. Okay na? So this is the size of attribute. Are you tell me? Total attribute length. This is the size of attribute. See, I told you router share the prefix as well as the attribute. See na, these are the attribute. What are those attributes? We will discuss these things in a detailed way. But right now, just understand, router is sharing prefix information along with the attribute. Now, I told you router share the prefix information that is called NLRI. See here, network layer reachability information. And when I open this, you guys will find the prefix information which you are advertising. So I am advertising 1.1.1.1. So that's the reason here 1.1.1 with subnet mask /32. Getting my point? Anyone who do not understand? Are tell me, anyone? I hope you guys understand everything. Clear na? So R1 is sharing the update message. So this is the update message. Are clear, everyone? Yes or no? Yes. Now this update message will hand over to layer number 4. In layer number 4, what is the source port number? Random port number. Destination port number is 179. Yes or no? Again, this will hand over to layer number 3. Layer number 3, what is the source IP address? 12.1. Destination IP address 12.2. Are you getting my point, everyone? Yes or no? Yes, no? Okay. So basically, this is the information in update message. Clear na? Total path attribute length. It specifies the total length of path attribute. Path attribute contains the attribute associated with the advertised routes. Yes, the routes which you are advertising, that path attribute is related to that path attribute related to that advertised route. Getting my point? These attribute help in the selection of best path. Yes, let's suppose R2 receive 1.1.1.1. Why R1? Sorry, why R1? And R2 is receiving not 1.1.1. R1, R2 is receiving the path attribute also. Getting my point? Let's suppose in any scenario R2 wants to communicate with 1.1.1.1. So R2 will choose the path. Getting my point? R2 will choose the best path. But now how R2 will select the best path? According to the path attributes. So that's the reason in the first class I told you, if you guys remember, BGP is a path vector routing protocol. Why? Because in BGP routers choose the best path according to the path attributes. Yes or no? Yes. And the next one is, guys, network layer reachability information, that is called NLRI. Getting my point? And in NLRI, what are the content? The prefix which you advertise along with the subnet mask. Yes or no? Everyone. I hope you guys understand it. Clear? Anyone who do not understand? Okay. Okay. So guys, I told you that time that this rule. Yes, na? Everyone. So what is the rule? First one, whenever you are advertising anything in BGP, first of all, you have to remember first thing, that prefix must be present in the local routing table, and that prefix uh, must match the subnet mask which is present in the local routing table. It means with the same subnet mask, you can advertise the prefix in BGP which is present in the local routing table also. Yes. Now, what is the rule number two? When we advertise a prefix in BGP, it get added to the BGP table. I already told you. If you advertise anything, router store that information in which table? BGP table. A prefix is determined to be best and valid in the BGP table. Router will also add in its routing table. I told you, when that prefix will be valid and best, then after router will store that information in its BGP table. Otherwise, no. See here. Let me first of all see here, everyone. We are on R6. Clear na? We are on R6. Come on R7. It means R6 already share 1.1.1 prefix. Why update message? Yes, it means R7 already received the update message. If R7 already received the update message, it means R7 already installed that prefix in BGP table. Yes or no? Yes. So what is the command? Show IP BGP. See, now R7 has 1.1.1.1 information, and what is the subnet mask? /32. And on R6, you already advertise with /32. So that's the reason on R7, this is also /32. What is this? Valid and best. It means on R7, 1.1.1 is valid and best. What is the next hop? Next hop is now 12.1. I told you, na? Generally you guys will find two things, either 0.0.0.0. On R6 you find 0.0.0.0. Why? Because on R6 you are advertising 1.1.1.1, and 1.1.1 is already present on R6. It means R6 is self advertising this. R6 is self-advertising this. Are you getting my point? It means the prefix which you are advertising, and that prefix is present in its local routing table, that is called self-advertising. So that's the reason next stop is 0.0.0.0. But on R7 you are not advertising 1.1.1.1. R7 is receiving 1.1.1 by R6. So that's the reason next stop is 12.1, because this is the IP address of R6. Getting my point? Everyone, yes or no? Yes. Now, one thing I told you, see na, this prefix is valid and best. If this prefix is valid and best, it means R7 install that prefix in its local routing table also. See na, so IP root. See na, R1, sorry, R7 install that prefix in its local routing table also. In its local routing table also. Why? Because in BGP table that prefix is valid and best. B means R7 receive 1.1.1.1. Why? BGP. So that's the reason B means BGP. Are you getting my point? Yes or no? Yes, na? Now, what is this? This is the AD value. I told you na, there are two types of AD value. There are two type of AD value we are using in BGP, 20 and 200. 200 in case of IBGP, and 20 in case of EBGP. Here on R6 we are using AS number 100, and on R7 we are using AS number 200. It means this is EBGP. So that's the reason R7 receive 1.1.1.1 with AD value 20. Are you getting my point, everyone? Yes or no? Yes, na? So this is the local routing table. Okay. One more command. So IP route BGP. So this is the routing table of BGP. This is the local routing table of BGP. Yes. See now, when I open the BGP table, when I open BGP routing table, see now 1.1.1 is present in its BGP routing table also. Yes or no? Yes. Okay. Now I hope you guys understand this one. Now, when a prefix from a router's local routing table is advertised in BGP, it means if any prefix which is present in local routing table, and if you are advertising that prefix in BGP, it means you are self-advertising. You are self-advertising. And when you check in BGP table, you guys will found next hop will be 0.0.0.0. Clear? Are you tell me? Yes, na? Okay, how can you check? So IP BGP. And I already told you about this one. This is called valid and best. This is called valid and best. The router share the best and valid prefix with its neighbor through an update message. This message include not only the prefix but also associated with path attributes. Again, I told you one thing, guys. See, when R6 is sharing the update on R6. Let's suppose when I advertise, first of all, think like this. This one on R6, I write the network command. When I check the BGP table on R6, that is valid as well as best. Yes or no? Okay. So if this is valid and best, it means R6 share this prefix. Why update message? Yes or no? This prefix will reach on R7. R7 install that prefix in its BGP table, and that is valid and best. Yes or no? Yes. What R7 will do? R7 install this prefix in its local routing table. Yes or no? Why? 12.1. Are yes or no? Yes. So the first thing, if any prefix is valid and best, router install it in its local routing table. Second thing, this router also share this prefix with its neighbor. This router also share this prefix with its neighbor. Getting my point? So this is the rule. If this prefix is not valid and best, this router number 7 do not perform two things. First, this router do not install in its local routing table, as well as this router never share with its neighbor also. But if this prefix is valid and best, in this case R7 install in its local routing table, as well as R7 share this prefix with its neighbor R8. Are you getting my point? Yes or no? Yes, na? I can show you na. Come on, R8. Let me check. So IP interface brief. IP address is configured. Okay, let me configure the BGP. Router BGP. Let's suppose which BGP? Are tell me. Okay. Neighbor. Who is the neighbor? 13.0.0.1. Remote AS is 200. Remote AS is 200. On R7, router BGP 200, neighbor 13.0.0.2, remote AS is 200. So TCP brief. See, with 13.1, TCP connection is already established. So IP, BGP, summary. See, with 13.2, neighborship is also established. Yes or no? Yes, na everyone? Are tell me. Now, so IP, BGP. 1.1.1 is present because R7 receive 1.1.1 by R6. Yes or no? So IP root, it is present in its local routing table also. Yes, and this is valid and best. Array on R7, it is valid and best now. See na, 1.1.1 is valid and best. It means if valid and best, R7 perform two things. R7 install that prefix in its local routing table, as well as R7 share this prefix with its neighbor also. Yes or no? Yes na. So IP BGP. See na, 1.1.1.1 is present in its local routing table also. It means R8 also receive update message from R7, and R8 install that prefix in its BGP table. Yes or no? Yes. One more thing. See na, on R8, R8 receive this one. Yes or no? Guys, one more thing. There is I. What is the meaning of this I? Any idea? See na, I means what? Internal. Internal means array R6, R7, R8. Here you are using BGP 100, 200, and 200. Yes or no? Yes, na? So, see, na, one more thing. Come on here, R7. When I write here, so BGP command. When I write here, so BGP command. Here, see, na, this is the prefix. And here you are not getting, na, I. Here you are not getting I. It means what? If you are not getting I, it means this is external. This is external. If there is nothing, if there is no symbol, it's blank, it means this is external. It means R7 is receiving 1.1.1.1 by R6, and on R6 you are using AS number 100, and on R7 you are using AS number 200. It means for R7, 1.1.1 is external prefix. Getting my point? But on R8, R8 is receiving 1.1.1.1 by R7, and on R7 AS number 200, on R8 AS number 200. So that's the reason on R8 you are getting I. I means R8 is receiving this prefix by R7 with the internal router. It means on R7, on R8 AS number is same, na? So that's the reason here you are getting I. Are you getting my point? Yes or no? Yes, na? See, here you are getting I. I means R8 is receiving this prefix. Why? Same AS router, that is R7. What is the next hop? Next hop is 12.0.0.1. Fine, these are the path attribute. One more thing, if you guys notice here, there is only a star, not greater sign. It means this prefix is only valid, not best. This prefix is only valid, not best. But why? We will discuss these things later. But right now, just understand this prefix is only valid, not best. And if this prefix is not best, it means R8 do not install 1.1.1.1 in its local routing table also. See na? So IP root. See na? 1.1.1 is not present in its local routing table. Not only this, even in BGP local routing table also. Getting my point? So that's the reason I hope now you guys understand. If any prefix is valid and best, then router will install in its local routing table as well as share with its neighbor also. If that prefix is only valid, not best, in this case, router do not install that prefix in its local routing table, as well as router never shared that prefix with any neighbor. Getting my point? Let's suppose if there are any other router R9, even R8 do not share 1.1.1.1 with R9 because this is only valid, not best. Clear? I hope you guys understand it. Clear na? Anyone who do not understand? Are tell me. Okay. Now there are some more rules, guys. Router use path attribute to select the best path. We already know, right? Now, these attributes include AS path, next hop, origin. What are these? We will discuss these things later, right? Now, and on the basis of these path attribute, router select the best path. That's the reason we called BGP as a path vector routing protocol, because in BGP, router select the best path according to the path attribute. Are you getting my point? Yes or no? Yes, no? Router only share prefix that are both valid and best. Yes, na, with its BGP neighbor. If prefix is only valid, not best, in this case, router never share with its neighbor. Clear? If prefix is valid but not best, router does not share this prefix with its neighbor. Are you getting my point? And not also install in its local routing table. Yes or no? Yes. I told you na, when you write this command, so IPBGP, if you find I means router is receiving that prefix from internally. Internally means same as router. Getting my point? If there is nothing, if it is blank, it means router is receiving why its external router. It means different AS. Are see na, blank, no letter in front of the prefix. It means roots was learned from external BGP. External BGP. Getting my point? Anyone who do not understand? Are tell me? Yes. Very good. Excellent. So till now, what we discussed, guys? Yes, component of the update message we already discussed, right? Okay, guys, there is one question. Question is update message triggered? Triggered means any idea? Yes, triggered means see guys, I told you one thing, periodically means after every 60 second or after every some period of time, router exchange the message. That is called periodic. Triggered means when required. When required, then router exchange the update message or any message, that is called triggered. So yes, update message is triggered, guys. Getting my point? What is update message is triggered? Update messages are sent when there are change in the BGP routing information. When there is change in the BGP routing information, in this case, router exchange the update message. But by default, router exchange the update message only one time. Getting my point, everyone? There are some scenario where router exchange the BGP update message again. What are those scenarios? For example, new route. For example, this is the router number 1. If you there is 1.1.1.1, you advertise this prefix in BGP. So this router generates the BGP update, and router exchange this update only one time. For example, if I configure one more loopback, that is 2.2.2.2, and I advertise this one in BGP, now again this router generate again update message. So that's the reason I am telling you BGP update message is triggered. It means whenever router learn the new route, or whenever you are advertising any new route in the BGP, router exchange the BGP update message. Are you getting my point? Yes or no? Yes. Now, one more thing. Let's suppose on router number 1, fine. Let's suppose I write here no loopback 1. Let's suppose I am removing this loopback. Again, R1 will generate the update message, and in this update message, what is the withdrawn routes? 2.2.2.2, because 2.2.2 is now not available in R1 BGP table. Yes or no? Yes. So please remember, update message is triggered. So if any new routes learn, router generate the update. If any routes are withdrawn, router again generate the update message. Yes or no? Yes. Path attribute change. Yes. Let's suppose if you change any path attributes manually. If you change any path attribute manually, in this case also router generate the update message, because we know in update message router generate what? Prefix information as well as path attribute. So if any prefix will add or remove, router generate the update. If any path attribute, if any changes in the path attribute, router also generate the update message. Are you getting my point, everyone? Okay. Apart from this, there are one more thing. When router can generate the update packet, what? See, please read, guys. When an administrator reset the BGP sessions, The router involved will re-establish the session, and during this process, they will exchange open followed by update. It means when an administrator basically reset the BGP neighbor. For example, R1 and R2. Let's suppose on R2 you reset the BGP neighbor. What R1 and R2 will do? Basically, R1 and R2 exchange every messages, open message, keep alive, every messages, including the update message. Are you getting my point? Including the update message. If you want, I can show you. See here. For example, let me close it first. Stop it. Start capturing. Okay. On R8, come on R7. On R7, so IP BGP. See na? So IP BGP, we already have 1.1.1.1. Yes or no? Are yes na? Okay. Now let's suppose I want to what? I want to establish the BGP session again, or I want to reset the BGP session. What is the command? Please remember, guys. Clear IP BGP, and you have to write the neighbor IP address. Clear IP BGP, and after that you have to write the neighbor IP address here. Clear IP BGP. Let's suppose 12.0.0.1. I write this command. See na, everything happened again. And I will show you in the packet flow here also. See, when I write this message, see everyone, if you guys able to see TCP connection established. Array, tell me, TCP connection established, yes or no? Array, see here. SYN ACK. This is called three-way, yes or no? Array, tell me, router number 2 send open message, 1 send the open message, then keep alive. After keep alive, update. Array, tell me, yes or no? Yes na? See na? I hope you guys understand it. Clear na? So basically, what are the thing here? When router can generate the update message, there are few things. Yes, update message is triggered when any new route is advertised in the BGP. Router exchange the BGP update message. When any routes are not available or no longer valid in its BGP table, in this case also router generate the BGP update message. Getting my point? If any types of path attribute change, router generate the update message. Or if administrator manually reset the BGP session, in this case also router generate the BGP update message. So basically these are the condition where router generate the BGP update message. Getting my point? Anyone who do not understand? Are tell me. Okay. And we already discussed about the BGP route advertisement rule. Yes or no? So when we are advertising any route in the BGP, we have to remember these conditions. So that route must be present in your local routing table with the same subnet mask which you are advertising. Yes or no? Yes. Okay. Yes. One more thing, guys. See, let's suppose on R1 I write here interface loopback 1 and write here shutdown. It means this is now not available in R1 BGP table. Yes or no? Are tell me. On R1, we already advertise 1.1.1.1 in BGP. In BGP, and R1 share the update, there is no problem. But after some time on R1, I am writing interface loopback 1, I am writing shutdown. It means manually I am shutdowning this loopback. So when I am shutdowning this loopback, it means this loopback is now not present in its BGP table of R1. Yes, na? So when we on R1, this route is not present in its BGP table, then R1 will generate which message? Update. Which message? Update. But in this update message, router do not share what? NLRI. In this update, router share what? Withdrawn. See na? In type is 2. In this update, type is also 2. But previously, what is the withdrawn route length? 0. Because in this condition, when you advertise the thing, there is nothing removing. There is nothing removing or withdrawing. So in this case, length is 0. But here, after running this command, we are removing now this loop back. So in this case, root length is 5 and withdrawn root is 1.1.1.1 with slash 32. It means now this root is no longer available in R1 BGP table. And by the help of this update message, R1 is telling to R2, you have to remove 1.1.1.1 from your BGP table also. Are you getting my point? Yes or no? Everyone, tell me. Anyone who do not understand? Yes. Very good. See, na, I will proof you if you want. See, let me see. Update message we already exchange here, right? Na, start capturing on R7. So IP BGP. See, 1.1.1 is already present on R7 BGP table, and this is valid and best. So IP root. This is present in the local routing table also. Clear na? Now come on R6. I am writing interface loopback 1 and I am writing shutdown. I am writing shutdown. So see na, first of all, what R6 will do? R6 remove this from BGP table. So IP BGP. See, in BGP table 1.1.1 is now remove. Fine. Are tell me yes or no? Yes. Now R6, what R6 will do? R6 generate the update message to inform R7. Yes or no? Come on here. See here. But update message router already exchange only one time, right na? But see na, router generate the router one generate the update message. Yes or no? Are tell me yes or no? Yes na? See here in this update message, up type is 2. Withdrawn root is something, right na? Now what is withdrawn root? 1.1.1.1. It means R1 is telling to R2 you have to remove 1.1.1 slash 32 from your BGP and routing table also. Yes or no, everyone? So when this update message will reach on R7, what R7 will do? R7 will remove this one from its BGP table. So IP BGP. R7 remove 1.1.1 in its BGP table. So IP root, not in the local routing table also. Are you getting my point, everyone? I hope you guys understand it. Clear? Are you tell me? Clear na? So this is there are two conditions when you advertise the thing. When you advertise any prefix in the BGP, router exchange share this update, and when you are removing anything from the BGP table, so to inform its neighbor, router exchange this update. Clear? So guys, basically this is all about the update message. I hope you guys enjoy the session and I hope you guys will like and share. Thank you very much, guys.